You study them on day 1 in a normal colony. On day 2, you give them excess food and study them on day 3. Surely, bringing food comes down on day 3 because they are not hungry. Feeding the larvae comes down, they are not hungry. But more interest was dominance behavior, that is aggression, comes down, and particularly the aggression directed towards known foragers comes down significantly. So, excess feeding brings down aggression. Now we can do the opposite experiment. We can starve the wasps, and now we should increase the aggression. And the way we do that experiment is we again study a normal colony on the first day. On the second day, we close all the doors of the cage and don't give them any food. So they are hungry, they are trying to bring food, but they can't bring the rest. On the third day, we open the doors and they start bringing food. And as we expected, we find that dominance behavior actually goes up on day 2 when the door is closed and everybody is hungry, but nobody is able to bring food. You open the door on day 3, food starts coming in, aggression starts coming in. And in particular, the aggression is directed especially at foragers. That is, when the door is closed, when everybody is hungry, the aggression is directed to those who brought food yesterday. You brought food yesterday, why are you not bringing it today? So you show aggression to this individual, not a generalized aggression to everybody else. So worker dominance behavior, by the aggression is usually called dominance behavior. Worker dominance behavior is used for the decentralized self-regulation of foraging by the workers themselves. Now, all of this is very unusual for a species. And we have the following problem. This is a species found in southern India. It's not found elsewhere in the world. Nobody else studied this species. Only we study this and we say it's different. Are the wasps unusual or are we unusual? We want some control. One way is to get someone else to study these wasps and say, yes, it's true. The other thing is, if we can study a wasp, which is not like this, and in our own hands, if a typical wasp behaves like a textbook wasp in our hand, then we have confidence, yes, this wasp is different. We are the only ones who studied this wasp. We have studied only this wasp, and this wasp is very unusual. It's not a very common species. It turns out that there is a related species called Raghavendra Gadagkar in the same place, and we made a little study of this, and we found that this is a typical wasp. It has read the textbooks, and it does exactly what a wasp of its kind should do. So even when we study it is different from the other wasps. That gives us a great deal of confidence. And that's why I said the first wasp forced us to look at the second wasp, just to add confidence to it. So we looked at this wasp. Similarly, they were paper nest, all individuals identical. There's only one individual who is the queen. So we said, how is the queen different from the other? We marked out the wasp. Now it's all known. It's easy. We marked out the wasp. We went time activity budget. We calculated rates of fighting, etc. per hour, and we did the multivariate statistic analysis, the cluster analysis, and sure enough, we got citrus fighters and foragers. Now, where is the queen? She is always a fighter. This is a normal species. This is a species which has read the textbook. Queen is an aggressive individual. You use the same methodology and you find that the queen is a fighter as one expects. So there's nothing wrong in our finding that the queen is not a fighter in the first species. So now you study aggression, calculate dominance hierarchy. The queen is always at the top. The queen is always the alpha individual. So this is a normal individual. And it is our finding that this is a normal individual that gives us confidence that the first species is not normal. It is different. That's why we do this for getting the confidence. So in this species we ask, so look at the queen here. It is the queen who is the most aggressive individual in the entire form is not so in marginata. One of the workers can be more aggressive in marginata, but the queen is always more aggressive than everybody else in the form. So the two species are really very different. So we call this the comparative approach. Comparative approach is very powerful in studies like this because combination of experiment and a comparative approach really allows you to get confidence in the conclusions that they come. So, as in a typical primitive view social species, queens are the most behaviorally dominant individuals in their colonies and are expected to establish and maintain their reproductive monopoly by physical dominance. This we have not studied, but we expect that. Of greater interest for us is regulation of foraging. How does that happen in this Because in other subspecies, it is the queen who is supposed to do this. So we ask who regulates worker activity, and we do a similar experiment. We study a normal colony, we remove the queen, and we put back the queen, and we study the queen. And here we expected that we remove the queen, work should stop. But it doesn't. You remove the queen, work continues. There is no difference whether the queen is present or not. Day 1, day 2, bring food, no difference, feed larvae. And the reason is very easy. When the queen is present, she is the one who will bite the foragers and make them work. When you remove the queen, there is a new potential queen. Who will do this job? Not anybody in the nest, not any worker, but the potential queen. In fact, if you look at the aggression, sure enough, there is a potential queen who has stepped up for aggression, and if you look at the queen and the average worker, the queen spends more time active, unloads the foragers and feeds the larvae. But when the queen is not present, this is done by the potential queen. So as I said, there is no difference in day 1 and day 2. So now here we looked at unloading, and we found that there is no difference in unloading between day 1 and day 2. Because on day 2, the potential queen unloads. And there is no difference in the contribution of the foragers. So the foragers do not have to go and feed themselves. They still are unloaded. And if you look at the rate of unloading foragers, then you find the potential queen steps up the unloading job. So the one individual takes over this job. So what I am getting at is in Cyathiformes, there is a standard, typical top-down. The queen controls everything. If the queen is not there, the potential queen. It's one single individual and there is a top-down. In Marginata, there is a bottom-up. There is no one individual who is in charge, but everybody does it. And there is a bottom-up control. So now we look at correlation, and there was no correlation between dominance and food crop. So aggression does not serve that purpose in the second species. There was a positive correlation in one data, but there isn't such a positive correlation in Cyathiformes. So the summary of the Cyathiformes is that queens appear to suppress this I am not showing you evidence for, but that's what we expect. Suppress reproduction by physical dominance. Queens participate in regulation of worker activity in queen right colonies, and potential queens participate in the queen-less colonies. In contrast to our Marginata, worker activities are regulated in a relatively centralized way. Now, as you can imagine, we would love to do the excess feeding and starvation experiment with this species. But those experiments are very hard to do, and the reason is very easy. Propylidia marginata is a wonderful model to study because the wasps are quite aggressive to us. They sting us when we try to replace it. And that's a good thing, I'll tell you why. Cyathiformes is not such a good model because they are very mild. They do not sting us. So you might wonder, why do we like wasps that sting us? If a wasp society is aggressive towards others and stings you, it maintains itself. And therefore you can study. If I mess with a Marginata colony, all it will do is it will sting me, but it will not run away. It will stay there and I can study it. The trouble with Cyathiformes is, if I do anything to it, it runs away. It leaves its nest, goes off somewhere. I would rather be stunned, but I have my system to study than a wasp which is so afraid that it goes. In fact, Cyathiformes seems to be a very mild species. It's very difficult to penetrate, very difficult to do experiment. You can't bring it to the laboratory. The first thing they will do is they will abandon the test. So we also have the impression that in Cyathiformes, they don't have that much commitment, that much attachment to their nest as Marginata has. And Marginata can afford to have that because they can protect themselves. They can sting and they can keep enemies away. So we are having great difficulty in studying the second species to the same extent as the first species because it's a very mild species which runs away rather than defends itself. So we are hoping we will continue to do our experiments. But the general point I want to make is that these two species of fossil wasps permit us, perhaps for the first time, to experimentally investigate the evolutionary transition from centralized top-down control to decentralized self-organized bottom-up. It is a general characteristic of primitive societies that there is top-down control. It's one individual in charge. And in the advanced societies, that there is a bottom-up.